So, we talked about a few different types of particles, one type being leptons. Now, a great example of leptons that we had is we talked about electrons, and then we used that to then discuss all the other associated electrons, the associated leptons, the muons, the tau, the neutrinos. We had things that were very similar to leptons, called quarks. And these quarks actually built up to make larger and larger fundamental particles. Well, not fundamental particles, but these fundamental particles of quarks came together to make larger subatomic particles, I should say. We had 3 quarks joining together, and we're referring to that as a baryon. And we had a quark and an anti-quark joining together to make something that is called a meson. Now, these two collectively can be referred to as hadrons. They are hadronic matter. What makes a hadron is it is built up of quarks, and it is under the interaction of the strong nuclear force. Now, we also introduced the idea of bosons, and we introduced the idea of gauge bosons, or mediators. Now, bosons were the things that were carrying these fundamental forces, like the strong nuclear force, the strong interaction that's helping these hadrons stay together. So that strong interaction was being carried by the gauge boson known as the gluon. We had the electromagnetic interaction being carried by the gauge boson known as the photon. So we've got a bunch of different words to try and describe not only these fundamental particles, quarks and leptons, but also these things they can build up, baryons and mesons, being hadrons. You might find those in places like the Large Hadron Collider. Now, baryons and leptons, we can refer to those as fermions. Now, why we can refer to those as fermions is because they have a spin that is not an integer. Okay, they have a spin, should write that closer so you can read it. They can have a spin that is not a integer. Okay, all of our particles, on top of having baryon numbers, charge numbers, lepton numbers, they have an intrinsic angular velocity. A lepton, a fundamental particle of a lepton, like an electron, has poles much like a magnet, and this is causing it to spin much like the Earth. If the addition of these spins that make up these particles, whether it's on their own like a lepton, or 3 added together making up a baryon, do not equal a whole number, we can refer to it as a fermion. Any that does equal a whole number, we can refer to as a boson. So in actuality, a meson is a boson because it has a spin value that is a whole number, that is an integer. It has a spin of 1. Okay? So we can start to cross over a bunch of these terms. You know, if we want to talk about a proton, for example, what is a proton? Well, it's a nucleon because it's found in a nucleus. It's also a baryon because it's made of 3 quarks. It is also a hadron because it's made up of quarks and is under the influence of the strong interaction. It is also a fermion because its overall spin is not 1, is not an integer. We can think about a pion. A pion is a meson because it is made of a quark and an antiquark. It is a hadron because it's made up of quarks and it is under the strong interaction. It is a boson because it has an overall spin which is an integer of 1. We can start to use loads of these different terms to try and talk about these different particles. Now, there's quite a lot of words, but once you start seeing the trends, hopefully you can internalize them a little bit better.